Exercise 8.4 problem 6 to 10 solution. The radius and the height of a right circular cone and that of a right circular cylinder are respectively equal. If the volume of the cylinder is 120 centimeter cube, then the volume of the cone is equal to, they have given us few options. So the key point is the radius and the height of both the cone and the circular and the cylinder are equal. And they have given us the volume of the cylinder, right? If you remember the formula, volume of the cylinder is pi r squared h and volume of the cone is 1/3 pi r squared h. So, if the radius and height are equal, the volume of this cone is 1/3 of that cylinder. So, which means 1/3 of 120, that is 40 centimeter cube. Okay? So, let's do that. So, volume of the cone is 1/3 pi r squared h. Volume of the cylinder is pi r squared h, but we know r and h are equal in this case. So which means the volume of the cone is 1/3 the volume of the cylinder. Is it right? 1/3 pi r squared h and this is pi r squared h. So volume of the cone is 1/3 the volume of cylinder. And we know volume of the cylinder is 120. Therefore, volume of the cone is 1/3 into 120, that is 40 centimeter cube. So, which is basically this option. Okay. Now, let's go to problem 7. If the diameter and the height of a right circular cone are 12 centimeter and 8 centimeter respectively, then the slant height is. They have given us the diameter and they have given us the height. And what is the formula for slant height? Slant height of the cone L is h square plus r square. Please be careful, this is radius and they have given us diameter. So, we will have to take half of 12 centimeter. Okay. So, the slant height will be h square, h is 8. Okay. And plus r square. R is half of 12 because they have given us the diameter. So, half of 12 is 6. So, slant height will be 8 square plus 6 square. 8 square is 64. 6 square is 36. So, 64 plus 36 is 100. Root of 100 is 10 centimeter. The slant height is 10 centimeters. So, it is option A. Okay. Problem 8. So, let's read the problem. If the circumference at the base of a right circular cone and the slant height are 120 pi and 10 centimeter, respectively, then the curved surface area of the cone. So they are given the circumference of the base of the circular cone and they are given at the slant height. The curve, this is a straightforward problem. The curved surface area is pi RL. Right? But we are not given, pi R is given, pi RL. So what we have to do is that circumference is 2 pi R and that is equal to 120 pi. That is what is given, right? The circumference is 120 pi, right? So what will happen? So this pi and this pi will cancel. Okay. And so you'll get 2R is 120. So R will be 120 by 2, that is 60 centimeter. Now you can use this. The curved surface area is pi RL. We know the radius is 60 centimeter and the length is also given, that is 10 centimeter. Right? It is given here as 10 centimeter. Right? So, basically, curved surface area is pi into 60 into 10, that is 600 pi centimeter square. And that is option B. Okay. So, the key is the radius they have not given us directly, they have given it indirectly. They are saying that it is a circumference. Okay, so from circumference you'll have to find the radius, then use the height which is given here to find the curved surface area of the cone. Okay, so now let's go to problem 9. If the volume and the base of the right circular cone are 48 pi centimeter cubed and 12 pi centimeter square, this plus is a mistake actually. Okay, ignore it. Respectively, then the height of the cone, the volume and the base area of the right circular cone. they have given us the volume and they are giving us the base area, right? What is the volume of the cone? Volume of the cone is 1 by 3 pi r squared h. But what is pi r squared? That is the base area, because the base is a circle, into height. So in this case, we know volume is given and the base area is given. So which means this can be calculated. So all we need to do is substitute the values in this formula and simplify it. You will be able to get it. So volume of the cone is 48 pi. Base area is 12 pi. If you see here, it's given. Okay, 48 pi and 12 pi. Okay, into height. So height will be, so now let's just cancel. So this pi and pi will cancel and 3 will go 4 times here. So height will be 48 by 4. So that will be equal to 12 centimeter. And which option is this? Option D. Okay, so instead of giving us the radius and the height, they have given us base area and the volume of the cone. So normally we have volume of the cone is pi r squared h, right? So if you remember, or I think let me write it here. So volume of the cone is pi r square. But what is pi r square? Okay, it's very difficult, right? Okay, what is pi r square? That is the area of the circle at the base. So that is what I have rewritten as 1/3 into base area into height. Okay. So now let's go to the problem 10. If the height and the base area of the right circular cone are 5 and 48 square centimeter respectively, then the volume of the cone equal to is just the inverse or converse of the previous problem. So volume of the cone is 1/3 of the base area into height. They have given us a base area, they have given us a height. So substitute them in this formula and they get the volume of the cone. So 1 by 3 into, what is volume of the cone? Volume of the cone is given as 48 and the height is given as 5 centimeter. So it is 48 into 5 divided by 3. So let's cancel this. So 3 will go 16 times, right? So 16 into 5 is 80 centimeter cube. And which option is this? Option C. Okay, so I hope it's clear. If not, please go through this one more time. It will become clear. Thanks for watching this video.